On this episode of Embedded Insiders, Brandon and Rich ponder the possible reasons NVIDIA's acquisition of ARM is on the brink of collapse. After considering how difficult the IP company is to move to other semiconductor giants, they recall how Venkat Matella, former CEO and founder of Redpine Signals, was able to move some of his IP to Silicon Labs. But the operative word there is some, as he's using what remains to launch a new, low-energy supercomputing chip startup. Then, Steve Douglas, head of market strategy at Spirent, talks to Associate Editor Tiera Oliver about the 5G trends we can expect to impact the embedded edge in 2022. It's not about how connected you are, it's about how connected you and your devices are going to be with tech from 3GPP Release 17, Release 18, and beyond. Finally, have you ever tried to build a smart sensor? If you're not steeped in writing sensor firmware, even if you have tried, you probably didn't get very far. But if we can't create smart sensors quickly and at scale, how will we ever realize the full potential of IoT? It's standardization time as Brandon reveals the latest specification from the PCI Industrial Computer Manufacturers Group, or PICMIG, which is designed to make smart sensor configuration so simple, even a product manager could do it.
Good afternoon. Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise, here for this week's Embedded Insiders. I'm here with my partner in crime, Editor-in-Chief Brandon Lewis. Hello, Brandon. How are you?
Good. How are you? You're still leading the IoT franchise too, right?
Well, it's all sort of bundled in together. Embedded computing design is IoT, it's industrial, it's security, it's AI, and it's all that other stuff. Yeah, I probably used to say that, but IoT is not a thing anymore. So I don't even talk about it anymore because everything's just connected. So IoT to me isn't really something that we should break out separately.
Just is.
It just is. Exactly. So some pretty interesting news this week. It looks like, as I said, I think I did predict this and predicted correctly that NVIDIA seems to be no longer interested in ARM.
Cry face.
Is that your emoji?
Yeah, the cry face emoji.
I think that happens to be very good for the industry that it's not going through. I didn't believe it was ever a good thing for the industry to have them under the NVIDIA purview. So I won't say I'm happy about it because it doesn't mean that much to me, but I do think it's a good thing. I don't think it's the end of the line for either of these companies, in terms of the pursuit of what they're trying to get out of it, but it'll definitely push it out for many months, if not years.
Maybe NVIDIA should go buy MIPS.
I'm actually not sure if you're joking or not, but
I halfway am, but
that does make sense.
Yeah. So it said you think it's good for the industry. The last time we spoke about this, it may have been on the Embedded Executives podcast or somewhere we spoke about this. We said that we didn't think that it was going to go through, but we thought that ARM would be sold. And I think that's pretty obvious. SoftBank's going to unload ARM one way or another. And when you say that, I think this is, it's better for the industry that way. I don't know, because they're still on the market. I mean, what type of company is going to purchase ARM that potentially wouldn't have a negative impact on it? I've heard the names like Microsoft and Amazon thrown around. Well, aren't we? It's just a different evil, right? You're just talking about now having a company who wants to use ARM to develop their own data center chips, and is probably more of a software company than a semiconductor company and doesn't necessarily know how to manage that type of business. So it's not a NVIDIA who's going to dominate and create all these conflicts of interest around the chip design industry, but it comes its own whole list of problems itself.
The one that really jumped to mind for me is Intel, but they're not going to be allowed to do that for the same reason that NVIDIA wasn't allowed to do it.
Right.
And thinking it through, I'm not sure who would be able to do that for those same reasons.
Right.
Unless it is a software company that would be able to add to the architecture, not just use it for their own purposes.
Right.
Amazon is a pretty good example, actually. I think that could go through, and I'm not thinking about it for their internal consumption, thinking about it in terms of software tools that can be added on to enhance the architecture and make it a better architecture for the entire embedded industry.
Yeah, I do think that the most likely path forward is a company like that, like an Amazon, well, likely and best case, because as you said, any of the major semiconductor companies are going to run into the exact same problem that NVIDIA did. And, you know, Google, Amazon, Microsoft, I mean, that offers an intriguing play. You know, we'll see. I still believe that in the next year or two, we're going to hear about SoftBank selling ARM to somebody.
Yep. Well, I mean, it doesn't make sense for SoftBank to hold on to it. You know, they just want to make some money off this deal. They're not in the tech business.
Why they buy it in the first place?
To make money from it, to resell it.
Right.
So in other news, are you ready to move on to other news?
Yeah, I'm just such a sad topic. I hate when things don't happen. Got our hopes up, but yes, let's move on.
Okay. So I had a conversation with our old friend Venkat Matella, who, if you remember, was the CEO of and founder, I think, of Redpine Signals,
yep,
who was acquired by Silicon Labs for a fair amount of money. He resurfaced, and he is starting up yet another company who's doing very, very low power AI chips. So I had a conversation with him a week or so ago, and it's pretty interesting. At the time, he wouldn't really say anything. So we had another conversation where he was a little more forthcoming. And it turns out he didn't sell the entire thing to Silicon Labs. He held back some of the patents, and he's starting up this new company with those patents in the AI space. And they're producing 5 nanometer chips, which, as you know, is about as leading edge as you can get, to get the power down super duper low. Pretty interesting. And if you remember, when he was doing Redpine, most of the R&D was done out of India, and he's doing that again. Most of the R&D is staying in India, but the face of the company is in Silicon Valley. Pretty cool stuff. And you know, by the track record, you have to say this is going to be successful.
So it's complete chips. It's you know, off of a wafer and everything. It's not IP.
Yeah, they're not licensing IP. They're selling chips. That's the goal.
Wow. I mean, it's an expensive startup, huh? But producing 5 nanometer chips.
Well, they're going through TSMC, so it isn't like they're building a fab or anything.
Right.
But in the release, it says that the funding is coming from its founders, which, reading between the lines to me, you know, nobody told me this, but I would guess they're taking the money that Silicon Labs gave them and they're reinvesting it in this new startup, which is, I can't use the word I was going to use, the male genitalia. That
bold. It's bold.
Bold. Yeah, that's the word I was using to do that. And that's pretty impressive. You know, that's investing in yourself, saying, you know, I'm doing this, and I think it's going to work. So my hat's off to these guys, and I hope they succeed.
Yeah, good for them. So should we have Venkat? Should we add him to the board of NLOS?
Slow down. Well, if he wants to invest, then sure.
Well, certainly.
We can certainly use an investment partner, that's for sure. And
Venkat, for $10 million, you can be the chairman of the board.
Yes, and for those of you who missed the last episode, that is NAS Lewis Operating Systems.
For more on Matella's latest venture, Ceremorphic Inc., visit ceremorphic.com. Next, listen as Steve Douglas, Head of Market Strategy at Spirent, tells all about what's next for the 5G rollout, including the exciting new capabilities we can expect from the standard in the coming 12 to 18 months, and looks even further down the road to what's in store with 6G. So, where are we with 5G today?
Most of the early 5G networks that are deployed globally today are something called non-standalone. It's basically the 5G radio part of the network has been added or bolted on to the 4G LTE networks. The downside is that reality, the performance of 5G has been a little bit lackluster because it is a little bit hindered by being still dependent on many of the LTE network's capabilities. So what sort of is happening, and there's been a number of service providers have started that upgrade journey to move to the complete sort of, I would say, the full fat 5G version. We're tracking about 90 plus global service providers who are in the midst of trialing and doing sort of RF processes to select vendors so that they can do this move. And it's a key sort of requirement to help them not only sort of demonstrate to the market the true potential of 5G, it also gives them the opportunity to start engaging more and more with the enterprise and the industrial sector, because many of the use cases that those sectors require sort of that full fat version of 5G to be available. They're not as actually private 5G networks. We estimate at the moment there's roughly probably globally about 1,000 4G LTE and early 5G private networks today. But we expect this to dramatically increase over the next 3 years to potentially somewhere over maybe 10 to 15,000 of them. And this is being driven a lot by enterprises' digitalization strategies and the importance that they put on both 5G and Wi-Fi 6 technology as foundational connectivity components to allow them to actually exploit other technologies like IoT, big data analytics, and intelligent automation. So we expect to see a big push for 5G networks during 2022. And this will come probably in two major areas. One's around stadiums and events. We certainly see a huge opportunity for football stadiums, baseball stadiums, etc., to be turned into private networks. And some of the early work that was done in 2021 has demonstrated the commercial success of this, where these early private networks are able to provide new types of revenue opportunities in terms of immersive, say, experiences for the fans, and also help optimize just the running of those events and stadiums. And the other key area that we're seeing a lot of focus on and the testing of and expect to see early deployments next year is using then private 5G combined with that edge cloud in the manufacturing and energy sectors. So within our sort of power plants and large scale manufacturers. And they appear to be probably the two most dominant verticals at the moment. And again, there's this desire there that the private 5G and this edge cloud is going to provide a very secure and agile environment to allow them to start to totally, I would say, differentiate and optimize how they A, manufacture goods and services, or B, how they optimize the operations of some of these large factories and campus style networks. Good few examples of the potential of where 5G can help them, whether it's with the new frequency ranges providing the really high speeds and the very low cost coverage. For example, in one facility, rather than deploying hundreds of Wi-Fi access points, they've been able to deploy 3 or 4 small 5G cell sites to give them that complete coverage.
What is the status of communications like ultra reliable low latency or massive machine type?
In 2022, we'll see the first phase of really ultra low latency communications. So the latest version of the 5G standards were frozen just over a year ago. the first phase of network equipment is now becoming commercially available. And that introduces really the capability of how to do some of that low latency. We expect to see that coming into the service provider networks sort of early next year. It's not going to be the incredibly low latency that everybody sort of, I think, gets hyped a little bit. I think the ambition is to sort of have latencies at least beneath 10 milliseconds. And that's actually driven by a lot of today's, I would say, early use cases don't need the latency much lower than that yet. And that means you can actually realize quite a number of use cases today with getting to that level. As for massive machine type communications, again, a similar sort of scenario. Obviously, within 5G, the legacy technologies are fully supported within it. So these are sort of narrowband IoT, the early LTE, Cat-M, which is for the machine devices. That's going to be expanding to support also something called RedCap, which is really a reduced capability devices. So this is really to support really low energy, massive IoT devices on the networks, and also allow for very low cost sort of chipsets and modules for it. Now, this is seen as sort of I think as a critical part of making IoT and cellular a big success, because probably up until this point, most IoT devices using cellular have been sort of more expensive, more top end, so it limited their usage to probably really just the big mission critical sectors. I think with the new capability, this RedCap, this reduced capability, which comes in, and you'll start seeing it next year in the next few years, then you'll have very low cost devices, low energy efficient devices. And I think that's where you'll probably see the huge opportunity for IoT to really take off using cellular.
So are there any other trends or requirements we're going to see towards latency?
Around latency, a lot of the major applications inside the factories, like autonomous vehicles, like mission critical robots, require very, very low levels of latency. And this is becoming a little bit of the new battleground, whose network can actually deliver not only a very low latency, but one which is consistent and deterministic, so it doesn't fluctuate, to support these mission critical types of applications. We expect you're going to see this become a greater battleground in 2022 as the large service providers start to compete for the hearts and minds of the enterprise sector. And the second sort of key area we're seeing quite a bit of focus on is the use of metamaterials, reconfigurable intelligent surfaces, a research area where we can create printable materials which could cover everyday objects. So you could have them on the sides of your buildings, you could coat your vehicles, you could coat any everyday object in these materials. And they allow for the radio signals to be intelligently redirected and even amplified off. And as an industry, you would need to have less radio cell sites because all of the surfaces around you that are on our buildings, on our cars, could be covered in this, and they would act as part of the radio network. They would intelligently redirect the signals to where they needed to get to. This could be a pretty big game changer in how we architect and build networks of the future, but also it could be hugely beneficial from a sustainability point of view, because these types of surfaces are low energy consuming. They don't need very much power supplies, in some cases zero power. And again, the more cell sites who consume power that we can reduce, and the greater coverage we can provide would certainly reduce energy consumption across the network in a huge way. And I think that's going to be we sort of expect to see some of this come into the 5G system in the next few years, but it's definitely a target architecture for 6G.
Where are we with the 3GPP release, 17, 18, and so on?
I would say the slight delays because of the whole sort of pandemic. The current sort of tracking on them is release 17 is targeted sort of for a Q3, second half of 2022. And then release 18 sort of still, the ambition is for sort of mid 2024. So the one thing to take in mind though is once a release is available in terms of it gets frozen, it takes roughly another year and a half before the network equipment providers' solutions are available on the market. It takes probably a year and a half before you actually see that capability come into the networks. Sometimes you see a few early features, but that's typically the sort of pathway. So, if release 17 as a standard becomes available in late 22, you'll probably not see it in any of our service provider networks to early 2024. What I would say is though is some of the capabilities that are coming in are very exciting. So release 17 certainly brings in a couple of I think major enhancements around positioning technologies to give us really accurate positioning both indoor and outdoor. Now, this is seen as really important for quite a number of use cases, especially around, say, connected vehicles and autonomous driving, where they can feed into those systems to provide very highly accurate locations. And I think the other key area is something around Wi-Fi convergence. So, historically, Wi-Fi and 5G have maybe been seen as, either competitive or they sort of have to coexist. The standards now introduce an architecture which allows them to actually converge so that you can have the best of both worlds seamlessly. And this is seen as really, really important, especially in the enterprise environments where a lot of enterprises today are Wi-Fi. 5G will be coming into that environment. It's really, it's a real pain to people if they have to switch between them all the time, and that switching is complicated or it creates delay. So if you can seamlessly hand over between the technologies, without having to go through any complexity like re-authenticating again, or your session has to get dropped, or the video or that gets lost, then I think this is going to be massively valuable, and that's a key capability which comes in release. It starts in release 16, but it actually really, I would say, comes to a strong position in release 17. And then release 18, I think there's a couple of major enhancements that are I think critical for the future of our networks. One is around enhanced energy savings. So there's a lot of work already going on in 5G around sustainability in terms of how we make our equipment more efficient, energy efficient, how we use circular economies in terms of recyclables, energy reharvesting. In release 18, there's a heightened focus on this, on how we actually use technologies like AI and machine learning to optimize how the network performs, to focus on energy efficiency as a key metric. I think that's going to be critical as for long-term sustainability within the sector. And the other key area is probably around unmanned aerial vehicles. There's a big enhancement in the 5G system to support these types of unmanned aerial vehicles to make sure that they have consistent coverage and connectivity. So as they are being flown beyond line of sight, that you can guarantee their flight paths. You can guarantee that they're always going to be connected. The industry is already on the journey towards 6G at the moment. This isn't a big surprise. Most generations of cellular take about 8 to 10 years to define from sort of a vision setting, requirement setting stage to the standards are available. So it's on part of that sort of 10-year journey at the moment. I think what the big trend at the moment, though, is the government investment, which is being positioned towards 6G. I don't think as an industry we've ever seen this amount of investment being made available for early research around the technology. And this is because a lot of the governments are identifying sort of 5G and then 6G as sort of key enablers for GDP growth and enabling sort of new innovation in the markets.
So where are we now, and what can we expect in the future when it comes to 6G technology?
We're seeing a lot of focus on at the moment in the early 6G research, low Earth orbit satellite technologies, which are already sort of designed and being designed to be used in the 5G system. But we're starting to see more specific use cases of how satellites would be part of the overall 6G architecture to provide that sort of ubiquitous coverage anywhere across the globe.
For more information on the global 5G rollout, check out Spirent's 2021 5G report at spirent.com/assets/the Spirent 2021 5G mid-year addendum. Now, Embedded Computing Design Editor-in-Chief Brandon Lewis helps explain the latest industry standard for smart sensor development, PICMIG IoT Point 1, in part 1 of a 2-part series.
Data is the foundation of smart factory and Industry 4.0 value, and that data is captured by sensors at the edge. Transforming that data into intelligence requires the convergence of the IT and OT domains, which begins with smart sensors. At a basic level, smart sensors are what they sound like: data acquisition endpoints that integrate some amount of logic for identifying, filtering, and transmitting points of interest from captured data onto other systems. Of course, it's more than that, especially if you're an enterprise professional who needs to capture and analyze operational data in business intelligence efforts. Smart sensors use sophisticated firmware that's usually written by embedded engineers with years of experience, and that firmware must be validated and tested to ensure production sensors operate reliably and as expected. For non-engineers, this is enough to stop a smart sensor initiative before it starts. But for Industry 4.0 to deliver on its value proposition, technologists of all skill levels must be able to develop, deploy, and manage smart sensors with ease. PICMIG's IoT.1 firmware specification was designed with that in mind and offers a simple, no-code path to creating smart sensors that makes this process easier than ever before. To understand how PICMIG IoT.1 makes this possible, we first need to understand exactly what makes a smart sensor smart. What differentiates a smart sensor from a traditional sensor is the ability for it, and by extension any host, to interpret data in a user-friendly, human-readable format. You should be able to plug a smart sensor into any device and have it, and its output, be recognized right away. Just as you plug a mouse into a computer and it is immediately recognized as a mouse so you can start navigating with your cursor, any system you plug a smart thermistor into should immediately read its outputs as degrees Celsius or degrees Fahrenheit, and the value of the outputs as natively formatted on the thermistor. The magic behind all this is firmware that reads electrical signals generated by the sensor and uses a set of predetermined parameters to output usable data to the host. But unlike the homogeneous world of consumer PCs and mice, sensor integrators often write their own custom firmware and device drivers. While this doesn't add much, if any, value for the sensor manufacturer, it creates massive interoperability issues across sensors that segment the market, and not in a good way. Recognizing this and the need for technologists of all skill levels to be able to develop smart sensors quickly and easily, PICMIG developed the IoT.1 firmware specification. The PICMIG IoT.1 specification defines a standard firmware data model that was designed with simplicity in mind. It can be used by sensor manufacturers to transform normal sensors into smart sensors, and by OEMs and system integrators to pull data from any smart sensor into any design with ease. With PICMIG IoT.1 as a foundation, anyone should be able to configure a smart sensor in minutes. But in order to do that, it's necessary to understand the PICMIG IoT.1 data model and how it fits into smart sensors. A data model, for the uninitiated, is a structured way of organizing data that contains specific rules or instructions for how that data is packaged. In situations where you're dealing with vast quantities of data, data models help keep data accessible and easily managed. Think about it as a database record consisting of multiple predefined fields. The data model for a car, for instance, might contain information about the make, model, color, trim style, total miles driven, and so forth. Having a common database representation, or data model, that can be used for all cars makes operating on a vast database of car data simple, since all the records contain the same fields. Similarly, a smart sensor data model might configure the unique model number, minimum and maximum values, readout types, and linearization of a smart sensor in preparation for transport to a system.
In settings where there may be hundreds or thousands of sensors capturing data, like a smart factory, there could be dozens of different types of data. In these cases, data models are critical to keeping track of all that information. After all, data is only useful if it's usable, and it's only usable if you know what and where it is. With PicMig IoT.1, users can specify the unique characteristics of their sensor using the specification's data model. From there, the IoT.1 data model organizes the data into predetermined fields based on the type of data it is, since every sensor has different fields that dictate the sensor's raw input, minimum and maximum values, and how the system is to interpret and send commands for that data. Then the data is ready for transport. When PicMig developed the IoT.1 data model, they selected two industry-standard communications protocols for data transport. The Data Management Task Force's PLDM protocol allows operation and interaction with the device's data model through predetermined commands. The MCTP protocol takes the PLDM requests and provides reliable data transport across the system hardware interfaces. One of the most useful aspects of this communication stack is the ability of the smart sensor to notify the system when it has been plugged in. Upon receiving a discovery request from the sensor, the system can query the device, receive its data model, and integrate it into the system as necessary. Plug-and-play device discovery would be impossible without the data model. Next, we'll learn how to configure the sensor's firmware by specifying the data model so that the smart sensor can later be discovered by the system. But that's next time on the Embedded Insiders podcast.
For more on PicMig IoT.1, including detailed explanations, code samples, diagrams, and more, read the series Make Any Sensor a Smart Sensor with PicMig IoT.1 on the embeddedcomputing.com website, or find a full picture description on PicMig's industrial IoT initiatives at picmig.org/industrial IoT overview. Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.